Hi, good afternoon. This is Mr. Cassidy, and today I'll be covering Chapter 3, Lesson 4, Linear Equations in Standard Form. And we're going to jump right into it today. This is in Big Ideas IM1 textbook. Let's begin. Our first ideas are about vertical and horizontal lines. And so let's explore this in the first graph. Notice that I've got two coordinate pairs, and what they both have in common is that the x part of the coordinate is 3. X equals 3. The y part's varying. It could be anything here, but the x part is constantly 3. Well, this does make an undefined slope. And in this case, it makes a vertical line. And honestly, this is the equation. X equals 3 means that x will be 3 everywhere on the graph. Y could be anything, but x will remain 3. And so to graph it, I just go to 3 on the x-axis and then move up or down to fill in the coordinates. Now I do have a trick. Since this is a vertical line, and you may want to write this down, V for vertical, if you flip it over, like have a little mirror there, notice that becomes the letter X when I flip over that letter V. So an X equals 3. When there's only one letter, we know it's either horizontal or vertical. In this case, if it's only X, it's vertical. And we can remember that because of V flipped over gives us the X. Now, how about on the second graph? Well, here I've got several coordinates, but the Y value is consistently the same. Now, here I've got Y is 0, but let's imagine that it was actually at Y is 1. Well, Y equals 1 would be my equation here. It would mean that Y is going to be 1 no matter what. And I can put a dot at the Y-intercept at 1 and graph left and right. Now, in this case, Y equals 0 would be the x-axis. And how we can remember that Y forms a horizontal line is the letter H for horizontal can be flipped over and becomes, if you sort of imagine a mirror, in a way, it becomes the letter Y. So when you see Y equals 5, if there's no other letter, then that means we are graphing a constant equation and it is a horizontal line. So go ahead and add this to your notes, that horizontal is when we just have Y equals a number. Vertical is when we have X equals a number. And again, the trick I think really helps to memorize the rule is to flip over the letter for V or H to know which one is which. So why don't you guys try that? Oh, and you should consider, are these functions? Well, the one on the left is not a function. That is a non-function because the vertical line would pass through it infinite times. Okay. So on page 77 of your journal, you'll see the practice problems we'll be going over today. Let's go ahead and start with number 1. First, is that going to be a vertical or a horizontal line? You should have said horizontal, and you would be correct. Now, go ahead and find the first dot that I would graph on that when x is 0. You should have chosen y would be -3. The first coordinate pair is there. And since I know it's horizontal, I'm just going to extend horizontally outwards. Awesome. Now, problem 2. Is that horizontal or vertical? You should have chosen vertical. Okay. What coordinate can you graph right away? We can graph when x is 2, y is going to be 0. And that's right on the x-axis at 2. X-axis 2. And we know it's a vertical line, so we can just extend the drawing up or down. Okay, so that covers horizontal and vertical lines. We're now going to do an exploration into standard form, and we're going to use a word problem to do so. So here's my scenario. I've got Marshall High School Athletic Association. They're selling tickets for the weekly football game. Students pay $5 and adults pay $10 for a ticket. So how much money would they get if 100 students and 50 adults bought tickets? Well, you should have done, 100 students times $5 a ticket, and then added that to 50 adults times $10 a ticket. And we would get 500 plus 500 is $1,000. All right. How about if 125 students and 75 adults bought tickets to the game? Well, same idea. We'd do 125 students times $5 a ticket, and then add the 75 adults times $10 a ticket. That would be 750 plus, let's see here, 125 times 5. I think that's 525. I'm just checking my math in my head. Sorry, 625. And then I would add those together, and we would get 1375. All right, and how about if 97 students and 116 adults bought tickets to the game? You should have gotten $1,645. Okay, using the same method as the steps before. Now, what if I needed to change that? What if I don't know the number of students and the numbers of adults? How could we write an expression for just the number of student tickets, the amount of money made by student tickets? Well, we could maybe do $5 per student, right? 5S, and S could represent any number of student tickets. How would you write it for adult tickets? Well, maybe something like 10A, right? That would represent the amount of money, $10 per adult, would be 10 times the number of adults. So what if we know now the total that we need to raise for this game? The football team is playing an out-of-town tournament. The athletic association needs to raise $3,000. That's the goal in order to send the team. So they're going to have the game, and they want to raise $3,000. How could we write an equation using the information above to get to the total of $3,000? And we don't know how many students or how many adults are going to be at the game. We could probably do something like this. 5S plus 10A equals $3,000, right? Because however many students and adults buy tickets, we need them to get to that total of $3,000. Awesome. So how many adult tickets would need to be sold to reach that goal? If just adults show up, no kids, let me write our equation again. 10A equals $3,000. How many adult tickets would need to be sold to reach the goal? Well, no students arrive, so we could just ignore that or do 5 times 0, right? And we would get 0 there. Plus 10A equals 3,000. So now I've got 10 times the number of adult tickets is equal to $3,000, and you should have divided by 10 to get that the number of adult tickets would be $300. 300 adults would raise $3,000, right? $10 a ticket, 300 adults, $3,000. Do the same thing for student tickets. If only students attend, no adults go to this game, how many student tickets need to be sold? You should have done 5 times S and 10 times 0, so we can ignore that, equals $3,000. And divide it by 5. And you should have gotten that the number of students who need to attend would be 600. 600 students would reach the ticket goal. So what if I wanted to graph that? Well, let's change our equation a little bit. We had 5S plus 10A equals $3,000. What if I wanted to change that and I made, okay, let's have students be our X values and adults be our Y. Well, we could change that to an equation. 5X plus 10Y equals 3,000. And let me go ahead and label my axes. So I've got X is the number of student tickets sold. And every combination on the line that I graph, y-axis is going to be the number of adult tickets sold. And what this means is that every combination of XY pairs gives us a total of $3,000. So let's go ahead and graph that. Let's see here. Maybe if I go by 50s, this will work. 50. Yeah, that'll work. So if I go by 50 tickets, 100, 150, 200, 250, 300, 350, 400, 450, sorry, going slow here, 550, and 600, that'll work. And let's go by 50s on the y-axis as well. 50, 100, 150, 200, 250, 300. So remember, if 0 students buy tickets, how many adults? Oh, that's right. We got an answer there. We had that 300 adults could buy tickets if 0 students bought tickets. Now, how about if 0 adults buy tickets? We had to have 600 students buy tickets, right? Well, those two coordinate pairs give us enough information to graph the line. We can just connect them, and I apologize that it's going to be a little bit sloppy. This line represents all the combos that raised $3,000. And what we just learned was how to graph using intercepts. We graphed this equation instead of doing the mx plus b method, which you guys are familiar with, where you use b for begin and m to move. We learned how to graph it using the x and the y intercept. So let's learn about what those things are. So in this equation, an intercept, if you could think about it as a football game here, intercept is when one team gets the ball. I like to explain this in class, although I'm not sure how well it'll translate to online. Is let's say we have two teams playing, the Y's and the X's, and the Y's intercept the ball. Interception. Well, you know how the X team feels when the Y's intercept the ball? Like 0. The y-intercept is always when x is 0. And then later on in the game, the x's intercept the ball, and then they run out of bounds right here on the x-axis. And do you know how the y team feels when the x's intercept the ball? Like zeros. The x-intercept is always when the y part of the coordinate pair is at 0. Here's an illustration of that. Here I have the y-intercept when the x is 0. That would be down here at negative 120. And we have the x-intercept at 4. That's when y is 0. Our goal today is to be able to graph using intercepts. So before we go on, let's take one last stab look at our football playing game. What does the y-intercept mean in this problem? This is a great IM1 question. So the y-intercept is right here. It's already been circled. And let me change my pen color so that I can really write better. If I can. There it is. All right, so what does the y-intercept mean? Well, the y-intercept was at 0, 300. What do those numbers mean? Well, they meant that no students bought tickets, but 300 adults bought tickets, and the total they raised was $3,000, raising the total of $3,000. Okay, I want you to take a stab at interpreting the x-intercept. The x value is 600 when y was 0. What does that coordinate pair mean in this scenario? Well, you should have said something like, if no adults bought tickets, 600 students could buy it, and it would raise the $3,000. Awesome. Let's move on. We're now going to get into the nuts and bolts of the lesson. Standard form means any equation where we write a times x. A could be anything. We have an x on the left-hand side. and a y on the left-hand side. And maybe we have a number in front of the y, and they equal another number, a constant. So ax plus by equals c. Now a, b, or c could be positive or negative, so I could write like 3x minus 2y equals 10, and it will still be standard form. And what we've done with that football problem and all the tickets is we've learned many of the steps that you'll need in this lesson. So I can go through them a little faster here. Here's an example, ax plus by equals c. Most of the time that'll be a diagonal line, but remember, if a is 0, if you just have a y equals equation, the graph is horizontal, whereas if b is 0, it's a vertical line. All right, moving on. Notice that this is what we call standard form. This is still a linear graph. It will still create a straight line. It can be rewritten. If we solved it, we could solve for y to put it into slope-intercept form, y equals mx plus b. And that's what you'll be doing tomorrow in class. Okay, so these are some of the features of a linear equation. I'm just going to run through them. Both x and y have exponents of 1. There's no exponent written there, but you could imagine a mini 1 there, and it would be an exponent of 1. They're not multiplied together. They do not appear in denominators, exponents, or radical signs. And a, b, and c are whole integers. That's usually what we want when we're looking at a standard form equation. So here's a brief example of linear and nonlinear. And again, I'm going to cover this next tomorrow so that we can cover this better. Linear is anything that looks like any of these, whereas nonlinear, notice you've got x times y in the first one, x cubed here, you have y as a denominator. Those are the kinds of things that'll make it nonlinear in an equation. Okay, but our first goal today is x and y intercepts. So what is the x-intercept of this equation, or this graph? You should have taken a look at it and said, okay, well, the x-intercept is here when y is 0. That is negative 2 comma 0. Okay, find the y-intercept. Okay, you should have chosen that the y-intercept was at 0 comma 1. All right, and if you need to review that, again, go back a little bit in the video to where I go over which values are 0 at the intercepts. Okay, so now that we know that, what if we need to find the x and y intercept from an equation? Now, notice this x with a little 0 means x-intercept, y with a little 0 means y-intercept. I don't usually write that, though. Let's not worry too much about that. So what if I need to find the x and the y-intercept here? Well, what I'm going to do is this. To find the x-intercept, I am going to make y 0, because when the x's intercept the ball, the y's feel like zeros. So I put 0 in for y like we did with the student and adult tickets. And we got 5x equal to 10. I divide by 5 and I get the x-intercept is 2, which means when y is 0, x is 2. Now, how about to find the y-intercept? Well, to find the y-intercept, replace x with 0, because it's just like finding the number of adult tickets. So I put in 0 for x, and I get negative 2y equals 10. Divide by negative 2, and I get y is negative 5. The y-intercept is at negative 5. And those are coordinate pairs I can use to graph. So go ahead and practice on 3, 4, and 5 on page 77. What are the x and y intercepts here? All right, the x-intercept of problem 3 is going to be, again, when y is 0, x. 3 times x equals 12, 4. I'm not going to solve it as slowly because I just want to save time. So how about the y-intercept? That's when x is 0 and y is going to be 3. Okay, how about number 4? What is the x and y intercept here? Let's start with the x-intercept. Well, We can start by saying when the x's intercept, the y's feel like zeros, so we put a 0 for y, and we solve for x. That would mean negative x equals 16, and we could divide by negative 1 to get our answer. X is equal to a negative 16 on the x-intercept. How about the y-intercept here? Well, same deal. We're going to put in 0 for x because the x team feels like zeros when the y's intercept. And I have negative 4y equals 16. Don't lose that negative. Divide by a negative 4, and I get y is equal to negative 4. Okay. How about the x and y-intercept for problem 5? I'm going to do them in my head. So my x-intercept would be when y is 0, x has to be a negative 6, and the y-intercept. The y-intercept is going to be 15. Okay, so moving right along, how do we graph using the intercepts? Well, here I've got a standard form equation. First, I find my x-intercept. Go ahead and find the x-intercept for this problem. You should have come up with the x-intercept was 3 when y is 0. How about the y-intercept? You should have come up with that y was negative 6 when x is 0. Oh, I messed up writing that. 0, negative 6. The x feels like zeros when the y-intercept. So to graph that, I'm going to go ahead and put my xy axis on the grid here. A little bit sloppy on that. Whoops. All right, and I'm going to go ahead and graph at x is 1, 2, 3. That's my x-intercept, y is 0. And my y-intercept, negative 1, negative 2, negative 3, 5, negative 6. There it is. And that's all we need to graph a line. All of the coordinates here are when x and y multiplied by the 4 and the negative 2 will equal 12. You can pick any other coordinate on the line to do that. So now it's your turn. Go ahead and graph number 6 and 7. I'll show you the answers in a second. Okay, first find the x-intercept. You should have come up with negative 3, 0, and that's going to be right here on the grid. Now find the y-intercept. You should have come up with 0, 2. 0, 2 is right here, and we graph it like so. Okay, how about 7? Find the x-intercept. X-intercept is at 2, 0. So at 2, 0 is right here. And now find the y-intercept. Y-intercept is when x is 0, y is 4. And that's going to be right there. Connect the two, and that's our graph. Okay, our final problem is a word problem, much like the athletic problem we started with, the game. Here we have baseballs and sweatshirts to raise $9,000 to attend a band competition. Sweatshirts cost $25 each, and baseball caps cost $10 each. Here is a standard form of a linear equation that models that scenario. X is going to be the number of sweatshirts, Y is the number of baseball caps. So first, find and interpret the intercepts. So what is the x-intercept here? Well, when y is 0, we do 25x plus 10 times 0 equals 9,000. And 10 times 0 is just 0, so now 25x equals 9,000. And to get that, we're going to do 9,000 divided by 25, which gives us 360. So the x-intercept you should have found was 360, 0. Now, what does this mean in the problem scenario, knowing what x and y are? You should have chosen, this means that you would sell 360 sweatshirts and 0 caps to make the total of $9,000. Okay, try the same thing with the y-intercept. What's the y-intercept of this problem? You should have come up with the y-intercept is at 300. Correct? Oh, no, wait, that can't be right. Divided by 10, 900. And what does this mean in the problem scenario? Go ahead and type it in. You should have said that would be 0 sweatshirts, I'm going to abbreviate, and 900 caps, making $9,000. Now, if 258 sweatshirts are sold, how many baseball caps will get sold? Go and try that yourself, substituting what you know. Well, we'd put 258 where the x is. 25 times 258 plus 10 times y will give us the total of $9,000. So 25 times 258 is 6,450. Add the 10y to get 9,000 and work outside in. We would subtract the 6,450 to get 10y equals 2,550. And when we divide by that $10, we get that the number of caps is 255. Okay, your last step is to graph. So first, you might decide on an interval. And this is really a conversation I like to be able to have in person. So think to yourself, what interval do you think I'm going to choose for the x-axis, knowing that we have to start at 0 here, but I need to get up to the x-intercept of 360. Try to decide for yourself. I don't really have an easy way to do this. If I did 30, it probably would run out of room. If I do 40, it might work. You could go up by 36, but that's going to be annoying. So I'm going to go up by 50s. 50, 100, 150, 200, 250, 300, 350, and 400. Okay, how about the y values? Try to decide on the interval I would use, knowing that you need to get all the way up to the y-intercept. All right, so I'm going to go up by hundreds. 1, 200, 300, 400, 500, 600, 700, 800, and 900. Okay, go ahead and graph it using the intercepts. We could put a dot here at 900, the y-intercept, and 360. Notice it's not right on the grid line, so I'm just going to go close to the grid, and I'm going to go ahead and connect the two dots. That's how we graph a standard form equation. And find two more possible solutions. I'm not going to go over that right now, but basically that would mean you'd find a pair, a coordinate pair that matches on the graph, and you'd find the solution. Like when x is 150, what is the y value? In other words, when you buy x number of sweatshirts, how many caps do you need? All right, that covers how to graph from standard form and how to interpret the graph as well. I thank your minds and your hearts, and I wish you a good math afternoon. Bye.